There you go, perfect. All right, so those are, for anyone watching on the left side there, those are the things that are due this weekend. At least progress check is on Sunday to help you prepare for the demonstrate understanding on Monday with the Frere model that is due on Monday for a test on Tuesday or Wednesday. Someone started saying something.
Nah,
Okay. So we're all about density curves. We're using that specifically with the normal distribution. And so yesterday we heavily talked about transforming the data. So remember, when we add or subtract, how does that affect the distribution?
wait, what?
So like if we add or subtract the entire distribution, if we add the 8 to the entire distribution, what does that do to the distribution?
Oh, it moves it right.
So it moves everything to the right 8, so it does what to the center?
The what? Increases by 8.
So the center increases by 8. What happens to the measure of spread?
It
Stays the same, okay? What happens to the shape of the distribution?
stays the same.
Stays the same. What happens if you have every value in the distribution?
The centering. Spread.
The center becomes what?
Half.
Half, right?
And then
The spread becomes
Half.
half, and then the shape
Same.
stays the
Same.
same. Remember, that's the whole idea of the standard normal distribution. What was that z-score formula, the standardizing stuff? There we go.
Value minus mean divided by standard deviation.
And notice I'm using the symbols, but reading that as it is, don't say x minus x bar. Value minus mean divided by a standard deviation. When we subtract the mean, we end up centering it at 0. When we divide by the standard deviation, we set the standard deviation at 1, okay? So the whole idea of standardizing is that we are creating this one standard normal distribution with a mean of 0, standard deviation of 1 all the way through. But it hasn't really changed the distribution, just the center and the spread. So we're going to be calculating and interpreting standardized scores today. We're going to be looking at percentiles. By the way, what is a percentile again?
it's like the
Someone do it.
Okay, so it's the percent that is
at or
below.
Below.
Below. Percentile is the percent of individuals that are at that score or below. Empirical rule, we're not talking about as much today, but what was the empirical rule?
68, 95, 99.7.
Got to know those three. 68, 95, 99.7. 68% of data is within one standard deviation. 95% of data is within 2 standard deviations of the mean, and 99.7 within 3 standard deviations of the mean. But we are focused here, using calculators to determine the area under the graph, and then we're really getting here, this is the thing we didn't get to yesterday, using the area to get the data value. Alright, so we did 6, 7, you said we need to talk about this one, Nate? So, in this one, not using that marker, go away. So in this one, we still have a standard normal distribution. What's weird about this one though?
It's like there's one value minus from the standard.
So, say it one more time.
What's like?
By the way, why did I draw my first line right here?
because there's a what you can call it
Inflection.
Point of inflection. Remember, that point of inflection helps me identify one standard deviation. It at least makes it somewhat accurate. Okay, so what's different about this one though than what we've seen in the past?
You have to set lower and upper bound.
You have a set lower and upper bound, but like other than that, nothing has really changed, right? I'm looking here at 193 seconds. What do I need to do to that?
On the z-score.
Find the z-score. Value minus mean divided by standard deviation. Do note, I've recommended this to several people already, start with your z equals. You need to practice labeling stuff. It helps make sure you don't make mistakes. What you looking for, Brayden? You don't need it.
Okay.
Yep. Every now and then I would just trade out calculators and let it charge, but yeah, you don't need the hats. That just connects to my computer. Okay? And so did you already do these? Did you already do these problems from last night? Huh? I'm trying to get you locked in. You seem a little tired.
I'm not tired.
Huh?
I'm not tired.
Okay. We got this. So remember, this is the mathematics stuff. And again, I would be taking calculators home if I were y'all, because this stuff is, I guess you can find online stuff to help you with it. It's just easier to use the calculator that you use on the exam. So what is the value in this case? Minus 220 is my mean, divided by 26. So what was z? Negative what?
I got point. I got negative 1.0.
How big a difference is 1.03 or negative 1.03 and negative 1.04?
It's rounding.
It's a rounding
Oh,
thing, right?
Gotcha.
If you want to make sure that it's not a rounding issue, you can actually put it into the calculator as this.
Yeah.
Like you can actually put that in. I would get the decimals to negative 1.03 though, ish. Boop. Just say mark it right here. What's my other value? 245. So 245 minus 220. So that gives me 25 divided by 26.
Yeah, which is
0.96.
yes.
Okay. So just less than 1.
Sorry.
And what do I need to find?
Portion of songs that are in between those two.
So the proportion of songs in between those two, the area, right? Okay. So notice I shade that region. Boop. And so what am I going to call this negative 1.03? That's the lower bound. This part is the,
Upper bound.
okay, just do that. Now what I will point out is, if you're worried about rounding, you can put that in as that fraction instead of the decimal.
Would it
You can put that fraction in instead of the decimal.
Would it be that much like a big deal for them though? Because it's like 038, so
038 means I would round that up to 1.04 or to down to negative 1.04. But look at the difference here. So menu, probability, distribution, normal, negative 1.03 to 0.96
yep.
versus negative 1.04 to 0.96. How big a difference are those? Not enough that they would count it against you, but what I will point out is, again, you can get more precise with doing negative 27 divided by 26 and just doing 25 divided by 26. That is as precise as it gets. It's not a huge difference. Does anyone know why that should make sense based on what we're seeing in that normal distribution up there? 0.68.
Because they're very close. to
Oh, it's
one standard
really close to 1 standard deviation above and below the mean, right?
Right.
Very close. Close enough that it's probably 68%.
Yeah.
Now, I would still use z-scores to be more precise, but that's there.
How much do we round to again?
A general rule of thumb is 4 decimals if you're dealing with probability and area. So 0.6823. The reason why I say that is, do you remember I mentioned there's those charts or those tables that you can use, but I live in the 21st century, so I use a calculator?
Yeah.
All of those charts and tables go 4 decimal places.
Why'd you put negative 1.03 on the board and put negative 1.04 again?
I did both. Because Nate said one of them and Braden said the other, and I was showing that it really doesn't make a huge difference. It's like, how big of a deal? As long as you label things well on the AP exam, you're gonna be fine. They'll give you credit for that. That's one thing to notice. You'll see sometimes when, if you look online, some people just write this notation on the AP exam. Don't do that. So like as evidence for what they're doing, if you draw this normal distribution and you write your z-score out, that will get you credit every time. So drawing out normal distribution on the free response questions, writing out what z equals to clearly show what the mean and standard deviation are, and then shading the right region, that will give you credit every single time.
So the menu thing on this calculator is the only way you can find it, like the area between.
I mean, you can literally type out norm CDF open parentheses like this, but yeah, I would just do the menu.
Yeah, but just on the calculator, there's no other way to to find it.
What are you?
Like if there's not like no.
It's not like a
equation.
button.
There's no like equation or like
No.
whatever.
Yeah, no. You got to know how to find your lower bound and upper bound, and go through that the menu.
So there's no like human way to like find it yourself.
Oh yeah, you can use calculus.
Oh, I really don't want to now.
Yeah, no, I don't either. I mean, okay, so let me show you this. I'm gonna be very quick because I want to get to the mathy side of it. So.
Yeah, that's why I meant like there's no like human like function or like equation.
There's not an equation, but so let me show you. So this is the free response from last year. But if you go to the end of the free response, there are what are called z-score tables. Okay? And in these z-score tables, it's showing you the area to the left of that z-score. So for instance, right here, if I look at this number, okay, notice that's negative 2.52. So the area to the left of negative 2.52 is 0.059. But these tables only let you find the area to the left. So if you're trying to find the area we were just looking at, what you would actually have to do is find this area, and then you would have to take out this area. So, you know what I'm using?
How would you do that?
I'm using a calculator all day long, huh?
How would you do that?
So if you look, so what was it?
I
So,
would not like
it's
to
the
apply
upper bound that we
calculus
just had,
to
right?
this.
Like, is it on that chart?
Yeah, so it was 0.96, right?
Yep.
So right here, 0.9 and 6. So right here, that's the area to the left of 0.96. So 0.96. So 0.8315. But remember, I didn't want this area, so I'd have to take away what is to the left of negative 1.03. So negative 1.0123. So let me ask you this, do you want to use the table or do you want to use the calculator? That's what I'm saying, baby. I used to force students to learn both. That's ridiculous.
Please don't.
That was way back in 2015. I was much younger and dumber then.
This is like on the test if you want to suffer and use it.
So, well, this also when the test was originally created. So the AP Stats exam was first given in 1998. Calculators like this didn't exist.
So they just haven't taken away the chart though.
Right, like they're not going to take it away. Because here's the thing also, God forbid this ever happens. Let's say your calculator craps out on you. You need a way to do it.
Right.
Now, what I'm going to do is I'm going to give you 2 calculators so that that doesn't happen. And you're only allowed to have one out on your desk at a time. But take 2, and if one craps out on you, grab a different one. Okay? But cool. Good talk. So yeah, we go just using the calculator instead of using the table and doing it by hand?
Yeah.
Yeah, that's what I thought. Okay.
So.
Good question.
I don't think I want to do
Yeah,
calculus
that's what
on
I
this.
did for my AP exam.
No way.
Yeah.
You did the chart?
Yeah, that's what we did for our stats class in college as well.
Yeah, you
Before
do
we
it.
used R.
Use that in theory probability.
Yeah.
Probably, yeah.
That's because teachers in college are still antiquated and sometimes forget that we live in the 21st century. And then magically it's like, oh, let's use R. And I'm like, you went from like the oldest form of statistics to like the most modern. Don't worry about what R is. It's cool. Okay, but does that answer our question here for number 7? That makes sense? Okay, so number 8 is much different. Oh, I didn't have it on here. No, what does number 8 say?
Many artists are paid on
Like what?
No, you're good. So, how long should an artist make a song if they want to be in the 10% of longest songs? Okay, so I want us to think about this. Every time so far when we've done these calculations, we have taken a z-score, right? And we use that z-score to find a what?
Percent.
A percent, or really we're finding an area and then we convert that to a percent, right? But now, what are we given?
The percent.
Now we're given the percent / area, and we want to find the what? Z-score. So what we have done is we had this input and we got this output. Now my output is the input. What is it called when your inputs and outputs switch? They're inverses. Interesting. Hold on to that idea for a second. So here's what I want us to recognize. So again, guess what? I'm dealing with a normal distribution, so you know what I'm going to draw? A normal distribution. There we go, right? Whee! That was a terrible normal distribution. That's fine. And I don't know exactly where I am on there, but where might I draw a marker to make this make sense? Remember, we want the longest what? 10%. So am I gonna like start here and shade this way, start here, shade this way, over here and shade?
Yeah.
Over here?
Yes.
No, actually even further more.
You think further here?
Oh, hold on.
10% would be.
I'll remind you of this. Remember,
it's
one
minus
standard
three.
Yeah,
deviation.
that's 95, so you
It's like
gotta
one
go
and two.
more left of that, right?
More left of it. Yeah, it's gonna be somewhere between one standard deviation above and two above.
Yeah.
Because two above is gonna have 2.5% here.
Yeah.
One above is gonna have 16%. So somewhere in between there. Somewhere, I don't know where. Even that though, I'll be honest, is more than you have to think about. But we want this area to be what?
0.1.
0.1, 10%, right? I really hope there's a way for the calculator to make my life easy.
That's what I was thinking, cause like I tried doing it yesterday, and like I was thinking about like the chart.
So let's look at menu.
Inverse.
Let's go back to probability or statistics, go back to your distributions. Does anybody see any options there that might make my life
Inverse.
easier? Oh, that's right, Lonnie, you said this is called my what again? Your inverse, so where am I gonna go? Inverse normal. Notice, what does it ask for?
Area.
The area. Now what area am I gonna put in?
0.1.
No, I'm not gonna put in 0.1.
No, wouldn't it be?
You would think that. Hey, but so I'm actually really glad I showed y'all a table a second ago. Do you remember on the table when it always shaded left?
Yeah.
Michael's like, I don't know what you're talking about.
Yeah, I don't
Okay,
know.
so remember how? So look, you see how it has that z-score marked and it's always shading left.
Yeah.
So on the and see there, it's also shading left. So on the calculators, they had to define which direction it was shading, or which area it's looking at. So this calculator always looks at the left area. So if 0.1 is on the upper side,
0.9.
I need 0.9 here,
Oh, okay.
right? So if 0.1's on the upper side, I need that 0.9 on the bottom
Gosh
piece.
dang calculator.
So be aware that you need the lower area.
I wish they just like did what and like just made it negative, like for left and then positive for right.
I have a question.
Go for
What's
it.
up with these areas?
Oh, don't do this.
I don't.
Those are all variables. You want the area, right? So put your area in. Leave the mean 0, the standard deviation 1, and... Alright, so I need my song to be 1.28 minutes long, right?
Yeah.
Oh, say that one more time? Oh yeah, that's right. The mean was 0 and the standard deviation is 1. So that's not how long the song is, that's
Z-score.
my z-score.
1.28.
Okay. You probably stop at 1.28. Z-scores typically do go to 2 decimal places, as you notice on the chart. But the more precise you are, the better.
So 1.28.
So I want y'all to work within your small groups at this point. I want you to use that z-score to find out how long that song is going to be.
Okay.
So that's your z-score. Use that to find out how long that song is going to be. Oh, I put that later. That was the issue. To make sure you have some more practice with this, let's do the check your understanding. Oh, you already did all the check your understanding.
I have a question. So,
Hey, no one else has done the check your understanding for this yet, though, have we?
I thought you told him to do it last night.
Like
I was just scared, but
No, the A and B here.
Because I saw I had done this,
Yeah.
done this, and I was like, I probably
Yeah,
should.
let's work on the check your understanding, which I think you still gotta work on this
Yeah,
part, right?
sorry.
So yeah, so work with each other. Let's work on the check your understanding once you have those notes
I
down.
have a question for
Go for it.
this one. Should we just round?
Woo, I got that on camera.
Oh, and you.
Yes, sir, Serena, Michael's
Oh, she
talking.
can hear me. I don't
Michael's
care.
talking trash.
So you're not messy?
But
I'm never
for anyone
messy. I'm just
watching,
telling
these
you.
are the answers that Peter did for the last mathematic lesson that's called normal distribution calculations practice. So if they're wrong, it's Peter's fault, not Mr. Kinney for not correcting him.
Yeah.
Just put the
That's
paper
just a
on
joke.
like the camera instead of saying the title.
I guess Peter had a decent idea. Whee!
Our front side school is very context.